Let's begin. Today's May 20th, 2024, and we're doing the Daily Turing Machine Puzzle. So today's puzzle uses 6 criteria cards and 6 verification cards. Let's go to turingmachine.info for the details. So the 6 criteria cards that are used in today's puzzle are 3, 5, 12, 17, 19, and 21, and uses the blue verification cards. And of course, above we have that unique identifier that you can always use to search for this puzzle on turingmachine.info and get the details. Let's go solve. So in our grid above, we've got our 6 criteria cards. We've got criteria card A, criteria card B, and criteria card C all on the top row. And on the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at the middle digit, the square digit, and compares it to the number 3. Should that square digit be less than 3, equal to 3, or greater than 3? Criteria card B looks at the triangle digit, the first digit, and will let us know whether that digit should be even or odd. Criteria card C will compare the first and last digit, the triangle and circle, and in comparing it will let us know that whether triangle should be less than circle, should they be equal, or should triangle be greater than circle. In the second row, criteria card D will let us know how many even digits there are in our code. Should there be no evens? Should there be 1, 2, or potentially all of them be even? Criteria card E will take the sum of the first 2 digits, the triangle and the square, and we'll compare the sum to the number 6. Should the sum be less than 6, should it be equal to 6, or should the sum be greater than 6? And finally, criteria card F will let us know if there are a pair of digits that are duplicated in our code, as in the example 131, or alternatively either have all unique digits 134, or the possibility where it's the same digit repeated 3 times. So remember, we're looking for a unique 3-digit code that will meet each of the following criteria. And we're going to use the proposal 314 to begin. So I'm going to start by testing B, and I want to find out whether that first digit is even or odd. Okay, so the Turing machine does not approve of my proposal. If I come back and look at the triangle digit in my proposal, it's odd. So it's basically saying, no, that triangle digit should not be an odd. It must be even. So what I'm going to do is I'm going to put in my notes for criteria card B in section B here that triangle is an even digit. Since it disapproved of my odd digit, triangle must be even. And so I'm going to come up above here and eliminate all of the odd digits from triangle. So it can't be 1, can't be 3, and it can't be 5. Okay, I think next I will test and find out if there is a pair of digits in our final solution. So that's criteria card F. Okay, so the Turing machine approves. Now notice that in my proposal I use 314. There is no pair, right? So it's basically saying, yes, I approve that there's no pair. So it could potentially be all different or all the same. So, but since 222, or basically a repeated digit 3 times, is pretty rare, I am going to put in my notes that I believe it's going to be all unique digits, but I'll still kind of have that hint that it could be the same digit. I don't know if there's a way to definitively eliminate it as a possibility. I'll just keep it in my mind. And so again, that's criteria card F. So I'm going to say all digits are unique. Okay, so that's criteria card F. I think now I'll test let me test how many even digits there are in the final solution. So that is criteria card D. Okay, so the Turing machine does not approve of my proposal. Notice that in my proposal of 314, I've got 2 odds to my 1 even, so the Turing machine does not like that. Okay, so what can we say? Well, we already know that triangle is even. So obviously, it's not that there are no evens. That's impossible. Triangle is already an even. And the Turing machine replied that it's not just the one even. So that means that it's either 2 evens or potentially all 3 are even. So I'm going to write that in my notes for section D, that there are either 2 or, well, let me spell it out here, 2 or 3 even digits. Okay, so there's no way to figure out just yet if it is 2 or 3, and so that does it for my initial 3 tests for my first proposal. I now have to consider how to construct my second proposal. So was there anything else? Okay, so I did eliminate that. I don't think I can cross out any numbers based on this potential. And all digits are unique or possibly the same digit repeated. So yeah, I don't think I missed any opportunity to cross out numbers. So that's not going to help. Let's see what I have not tested. I have not tested criteria card A that looks at the square and lets me know whether that middle digit is less than 3, equal to 3, or greater than 3. I also have not tested criteria card C that compares the first and the last. Let's see. And then obviously criteria card E, the sum. Okay, so I kind of like the fact that triangle is even, and the only way I could get a 6 for a sum is either it's 2, 4 or 4, 2. So I think I'm going to construct my second proposal with some combination of 2s and 4s in for triangle and square, and that may kind of also hint at the fact that it's going to be all 3 different digits. So I have to construct my circle in a way that that will help me also looking at C, and I think that's it. That's the only thing that'll help me. Okay, so I need either, well, the first 2 will be even. The question is, do I want to make it an all even proposal, or if I want to put an odd in there? So how would the odd look like? Well, if I construct my proposal as 2, 4, that would force the circle to be less than, and if it were less than, then it would force it to be a 1. Or I could do it where it's 4, 2, and then force the circle to be greater and pick 5. So it looks like it's down to 2, 4, 1 or 4, 2, 5. I really have no preference. I think I'm just going to say 2, 4, 1. So let me try that out. 2, 4, 1. Okay. So again, I'm going to test criteria card E for the sum. Okay, so the Turing machine does not approve of the sum being 6. So that means that the sum is either less than 6 or greater than 6. So let me write that down for in my notes in section E. So triangle plus square is either less than 6 or greater than 6. Okay. Can I make any conclusions about square? So if it's a 2, I could always add it to 5 to get something greater than 6. But you also have, well, it can be 2, 4. So I think the only thing I can say for sure is that it can't be 2, 4 or 4, 2, because that gives me a 6. But that doesn't let me actually cross out anything. I just have to keep in mind that I can't have that combination of numbers, 2, 4 or 4, 2. Okay. But yeah, I can still potentially have in the next round, or deducing that it's 2, 5 to be greater. What else could be greater? What could be 4, 3? Or, well, there's no pair, so it would be 4, 4 and something other than 4. Again, keep in mind that it could still potentially be all 3 digits, but you could have 4, 5 for the sum be greater than 6. Yeah, so I guess I'll just have to test other stuff and see if I can deduce that later. So let me consider either testing A or C. Which one do I want to test? Let me test. I think I want to see if I can eliminate any of the circle digits. So let me test criteria card C. And okay, so the Turing machine also does not approve of my proposal. So notice that if I look at my proposal of 241, triangle is bigger than circle. It does not approve of that. So that means that in my notes I've got to say that triangle is either equal to circle or less than circle. So let me write that down for C. That triangle either is equal or less than circle. So triangle is either equal or less than circle. Well, there's still a lot of possibilities. Obviously, all the equals are, oh, I'm sorry, I should be looking at triangle and circle. Well, that's interesting. If it's equal, that would mean that they would have to be the same digit, right? I know that triangle's equal. Triangle is an even. So if triangle and circle were to be equal, oh, that's interesting. Well, we know we can't have pairs. We know we can't have pairs. So it can't be 2 for triangle and 2 for circle and something different in square, unless it's the same one. And again, it goes back to the idea that it could be all the same. So in that case, if it's going to be the same, it's going to be either all 2s or all 4s. So we'll just have to keep that in mind. Or potentially triangle is less than circle. So for 2, it would be 3, 4, 5. If it's 4, it's just 5. And that's if triangle is less than circle. Okay, well, I don't think I'll be able to solve that without more information. So I think I'm just going to move on and test A. Okay, so again, the Turing machine does not approve of my square digit being 4, meaning it is not true that square is greater than 3. So that means that, Yeah, so it means that square cannot be 4 or 5. So let me cross out 4 or 5 for square, and let me write in my notes that square, and that's for A. We're going to say that square is either less than or equal to 3. Okay, so I've eliminated all those where square is greater than 3, so it's still those. What I forgot to do is for my notes for C, where I know triangle cannot be bigger than circle. I think I should be able to eliminate something. Yeah, I think circle can't be 1 because circle cannot be smaller than triangle, right? Because that's why this failed. So that means it can't be 1. Notice that I have a small 2, so it can't be smaller than 2, but it could be equal. It could be equal. And then you have a lot of these possibilities where either they're equal. Oh, okay, so this is interesting. Let's see. If I now look at my triangle and circle, so again, it's 4, so yeah, I guess it could still potentially be 4, 4, and 2, 2. Oh, this is interesting. If they are to be equal, I think that's true. I think triangle and circle have to be evens. Since those are evens, oh wait, but I think that's only for if they're equal. I think there's still possibilities where they're less. Yeah, 2 is less than 3, and 2 is less than 5, and 4 is less than 5. So okay, so no, I don't think I can make any conclusions. Oh my. Okay. So I did cross out some squares. I did cross out that one, the one in the circle, but I don't think I can eliminate more. Wow, it just seems like I still have way too many possibilities. Okay, so I think what we need to do is I need to construct my third proposal and keep A, C, and E in mind because they all have, it's a 50-50 essentially. I don't know if I have enough information to deduce. So let's see. If I want to test if the sum is less than 6 and triangle either equal to 3 or smaller than 3, what would kind of force the issue? If I were to pick, say for example, 2, 3, that is less than 6. What would that mean for circle? It could be 2, 3, 2. Oh, okay, so this is interesting. I think if I pick square to be odd, then that means that circle has to be even. Remember, I have to have at least 2 evens or 3 evens. Oh my, so actually I've got 4 criteria that I'm not positive on. A, C, D, and E. Wow, and I only have 3 proposals left. So let's see if we can not necessarily ignore D, but plan so that I don't have to test. So what are the possibilities for all evens? Well, again, we do have the possibility that they're all equal, and just for 2, because I've already eliminated this 4. So 2, 2, 2 is the only 3, is that right? 3-digit possibility. Okay, so if it's 2, yeah, so for this, it would be 2, 2. I need an even here. So 2, 2, 2 or 2, 2, 4. Now that would, I think that may be a valid all even. Yeah, so 2, 2, 2 or 2, 2, 4. What if I pick 4 here? So it would be 4, 2. Okay, well it couldn't be 4, 2 because that's 6. So that would break the all even. So the only all even would be, well, the two are 2, 2, 2 or 2, 2, 4. That's the all even. So I think I'm going to write that down. And again, I'm not sure if I have enough space to, so we know we have either 2, 2, 2 or 2, 2, 4. 2, 2, 2 or 2, 2, 4. Because, yeah, 4, 2 is not going to work. Okay, so again, as far as all evens, all right, so let's see, are they ambiguous? Can I somehow conclusively eliminate them because I don't know enough? So in both cases, square is less than 3, right? That middle digit is 2. Triangle is even, yes. In this case, okay, that's what would distinguish them. See whether they're equal or triangle is less than circle. Okay, so they're not ambiguous. So I can't just eliminate them then, because this will kind of break the tie, so to speak. Okay, but you know, sum-wise, yeah, they're both less than 6. Okay, but again, I think that's the only all even potential solutions. Yes. Okay. So now what about 2 evens? So I can still have 2, 2, and then it would be 3, 5. So it would be 2, 2, 3, 5. Are those ambiguous? So in both those cases, triangle are less than 3. Triangle is even. In both cases, triangle is less than circle. I guess if it's true that there's only 2 evens, you know, yeah, they have 2 even. But it can't. Oh, you know what? I can't have 2, 2, 4 because that has a pair, and we definitely know there's no pair. So okay, so this is out of contention. Okay, so it looks like this is the only all even potential. Okay, so let's now consider, yeah, we were talking about now 2 evens and an odd. So let's break it up this way. Let's have the first 2 be evens and then an odd for circle, or odd in the middle, because we know triangle is definitely a circle. Okay, so let's test that out and see how many potential solutions there are. Okay, so we'll start off with 2. We said that we're going to have an odd in for square, so that's 2, 1. It can't be 2 because you can't have a pair, so it's got to be 2, 1, 4. Okay, and then it could be 2, 3, and then of course there is no pair, so it would have to be 2, 3, 4. Okay, what else? I think that's it for triangle being 2, 2, 1 or 2, 3, and then picking an opposite, yeah, the 4. All right, what about 4 then? Again, we're picking even, odd, even. So 4, 1, and then 2, and then 4, 3, 2. Okay, so that's a lot less than what I thought. Okay, so again, 2, 2, 2 is my only all even. and then these are, it seems to be the only potential um, um, unique digit. So yes, so this is all repeating, these are all unique, and these are all the two even. So I think what I did was, did I, oh, okay, so for the case it can't be that triangle and square are both even, this would give me a pair, and then this would give me a 6, both invalid. So yeah, so indeed, yeah, for the two even and one odd, it's got to be even, odd, even. So yeah, so 2, 1, and then switch 4. 2, 1, and then, oh wait, 2, 1, 4, and then 2, 3, 4. Okay. And then 4, 1, 2, 4, 3, 2. Okay, yes. Okay, so this, let's see. So now let's analyze these and see, are there any ambiguous solutions? So let's look at the sum. So this has a sum of less than 6, less than 6, less than 6. This is the only one where it's greater. Okay, so what about the square? Well, yeah, so there's some variability. Some are less at middle digit, some are less than 3, some are equal. Less than 3 equal to 3, less than 3 equal to 3. Okay, so that's kind of a 50-50. What else? What about triangle and circle? So here they're equal. Here, I think they're always going to be different, but, oh, okay. So we know that triangle cannot be bigger than circle. Triangle cannot be bigger than circle. It failed right here. So let's eliminate triangle bigger than circle. So that means that it can't be these two, because 4 is greater than 2 in both cases. Oh wow, okay, awesome. So I can eliminate these possibilities. Okay, and so now since they're out of contention, let's go back sort of to the drawing board. Both of these have, well, no, the distinction is one is less than 3, the other one is equal to 3. Okay, so that differentiates them. So there's no ambiguity there. But in both cases, triangle is less than. So here, triangle is less than 4. Here, triangle is equal to itself, 2 and 2. Okay, so that's still sort of up for debate. So is this. And what about the sum? Okay, so it seems like I think we can conclusively say that the sum should be less than 6, right? So that's 4, that's a 3, that's a 5. So I think I can deduce that the sum is less than 6. Since those are the remaining possibilities, I don't have to test that. And of course, you know, are they all unique? So that's still sort of up for debate. Is it the repeated digit, or are they all different? Okay, so it looks like I got to test F, D, yeah, and wow, I still have 3 tests. How's that possible? 1, 2, or I should say 4 tests. One of those, I think you would think that you'd be able to eliminate. Okay, I got to construct, or I got to basically choose one of these possibilities. Again, I'm thinking that 2, 2, 2 may be, you know, so the probability of it being all the same being low. I think I need to test one of these. The question is which one. So this is 50-50. Let's see. I think I would want to test this last. and this last. I think I should focus on A and C. What makes A and C different among my answer choices? So I think if I say, let's look at the 214. So this would be less than, square is less than 3. Okay, so that would leave me with these two to pick. And then I could always test it. Yeah, okay, that's what I'll do. So let me pick 214, and then I'll test A, and then I should be able to figure the other one out. Okay, so it looks like it's going to be an 8 test solution, I hope. So let me pick 214. Yeah, 214. Okay, so let me test A. Is that true? Okay, so it does approve of it. So again, if I look at my proposal of 214, it does approve the square to be less than 3. So it can't be equal to 3. So I can cross the equal, the equal. So we know that it's less than 3. So that means it can't be 3. So let me cross out the 3 here. Okay, so it's not 3, so that means it's not 2, 3, 4. And so now the only difference is, well, you know what? I didn't consider that. So this is still the same, this is still no pair. So that, okay, I hope that didn't ruin it. Well, I guess the distinction is, are there 2 evens or 3 evens? I think that'll do it. What about, or I could test C. That's interesting. That's interesting. So, yeah, 2 or 3 should do it, but so should this one. Are they equal, or is it less than? I think the safer way to approach it, I think it would be C, but technically there is no difference. Both of them should give me the same, well, how can I say that? Both of them, if I tested either of them, should tell me which answer is correct. So, actually, yeah, if I test either, if it's true, then the other one's true. So that, yeah, so I think, but the C just seems a little bit easier to test. So let me test C. And so it approves. Okay, so, and what is that? C is comparing the first and the last. So it proves that the triangle should be less than, yeah, not equal. So let me get rid of the equal here. And so, so it's not 2, 2. So, okay, as I mentioned, that was always a rare possibility, but couldn't just ignore it. So it looks like 214 is going to be the correct answer. So let me just do here where they're not equal. Oh, this is interesting. On my board here, what would that mean? Oh, that triangle is less than circle. So if it's 2, it can't be 2. Oh man, I don't know. I don't know if I would be able to eliminate the possibilities. I mean, assuming that I've got all potential solutions written out. Well, 214 is the last one. Okay, so I guess we would deduce then that there are 2 evens and an odd. So, so it can't. So it has to be triangle and circle being, yeah. Triangle and circle would have to be the evens, and so therefore square is odd. So yeah, so that's why you can eliminate this 2. And so that would be 2, 1. It can't be paired up, so it's not 2, 1, 2. And we got to have at least 2 evens, so it's not 3 or 5. So yeah, 2, 1, 4. Okay, so it kind of works out, hoping that all the deductions are correct. So, boy, this seems like a long process. I don't quite know how long the video's been going. So yeah, so I'm going to state that the answer is 2, 1, 4. And so let's go to turingmachine.info and confirm that that is the solution. So 214. So test the code. 214. Okay, yeah, so I'm a bit relieved. That was a pretty lengthy process. So again, we're going to test, or we're going to question how long or how many questions are valid in our tests, and if we beat the machine. So let's go back and look at what was actually done. So we did BDF in the first turn, and so let's go to BDF, and B and D were incorrect. So the next round, all were wrong, and they were the alternating ACE. Let's see, ACE and then AC were correct in the third turn. Okay, so ACE, were incorrect, and then both A and C were correct at the end. And let's see how we do. Okay, wow, this is a major relief. I was really thinking that, maybe I missed something where I could have, and potentially I did miss something, but that I could have done it in less than 8. 8 was really kind of pushing it. But, we tied. It's still a win, so that's just great. Okay, well, if you enjoyed today's video, please give it a thumbs up so that others can find other videos on this channel. If you have a comment, if you saw that I did miss something, or you'd like to just give some input of how these videos are take shape, please submit a comment. I'd love to hear from you. And if you don't want to miss the next video, please hit subscribe to be notified for the next one. Well, that's it for today, and we'll see you next time.